Address lines are a crucial part of a memory system. They specify the location in memory where data is to be read from or written to. In the context of DDR, double data rate, SDRAM, synchronous dynamic random access memory, the DDR controller is responsible for generating and managing these address signals to access data from the memory modules. Here's how address lines are typically used with a DDR SDRAM controller. Bank address. DDR memory is divided into multiple banks to allow for higher concurrency during access. The bank address lines determine which bank is being accessed. Row address, RAS. Within each bank, the memory cells are organized in a 2D array-like structure. The row address specifies which row within a bank is to be accessed. Column address, CAS. For a given row, the column address specifies which column is to be accessed. This essentially pinpoints the exact memory location within a bank. Command signals. In addition to the address lines, the DDR controller also generates command signals like RAS, CAS, and WE, write enable. These signals dictate what operation, read, write, refresh, is to be performed. Multiplexing. DDR SDRAMs typically multiplex row and column addresses over the same set of address pins to save on pin count. This is done by first sending the row address with the appropriate command, like activate, and then sending the column address with a read or write command. Burst access. DDR memories usually access data in bursts, for example, burst of 8 for DDR3. Once the initial column address is specified, the DDR controller will access sequential columns for the length of the burst. Auto precharge. Some commands can be given with an auto precharge option, which means after the command is executed, the row is automatically precharged, closed, preparing the bank for the next operation. Address mapping. In systems with multi-rank, multi-DIMM configurations, address lines can be mapped differently based on desired performance characteristics, refresh requirements, or other considerations. This involves determining which address bits correspond to banks, rows, columns, ranks, and chip selects. Rank address. If a memory module has multiple ranks, then an additional set of address lines might be used to determine which rank on the module is being accessed. In a typical operation, the controller activates a bank with the appropriate row address. Once the row is activated, the controller can issue read or write commands with the specified column addresses. After the data transaction is completed, the controller precharges, closes the row, which prepares the bank for the next access. It's also worth noting that DDR controllers handle other complexities such as refreshing the memory, since DRAM loses data over time if not refreshed, managing data burst sequences, and ensuring timing specifications are met. The exact number and function of address lines can vary based on the specific DDR standard, DDR2, DDR3, DDR4, etc., and the density and organization of the memory module. Always refer to the specific datasheets for both the memory controller and the DDR SDRAM to understand the exact addressing scheme. Testing the address bus ensures that the address lines between your DDR controller and the DDR memory are working properly, and there are no shorts or opens between them. 2. Address bus test. The goal is to write to one address and then read from all possible addresses to make sure the data only appears at the correct address. Address bus test. Step 1. Write a known value to the first address of the DDR memory. Step 2. Read the value from every address of the DDR memory. The value should only be present in the first address. If it appears at any other address, then there is likely a short in the address bus. Step 3. Clear the first address. Write a different value or 0. Step 4. Repeat this for every address bit. For example, for testing the second address bit, you would write to the second address of the DDR memory, then read from all addresses to ensure the data is only in the second address, and so on. Step 5. Analyze the results. If there are issues, recheck your hardware design, PCB layout, and any soldering or connections related to the address bus. Address bus test.